Finally, the time has come. We're going to bring it all together to graph these polynomial functions. So, with each polynomial function, we're going to apply the leading term test to determine the end behavior. We're going to find the zeros and state the multiplicity, and we're going to find additional points so we can finally graph. Let's take a look at this function here. F of x equals x times 2x plus 3 times x minus 1 squared. So, to start off, if we were going to use the leading term test, first we have to determine what that leading term is going to be. So in order to determine the leading term, we don't want the factored form. So what I'm going to do here is I'm going to deduce what my leading term would be. I know this would be an x right out here, x. I see this 2x in front here, and I see this x is going to be x squared. All I did here is I'm finding out what's going to multiply to give me my first term. So here I had the x, here I had this 2x, here I had an x which will eventually be squared, and I can just multiply all these together. I don't need to distribute the whole thing out because I'm just interested in the leading term. So this here is going to give me x times 2x, which is 2x squared, times x squared, which is 2x to the fourth. So my leading term is 2x to the fourth. I notice that we have an even degree, so my end behavior is going in the same direction on the left and right, and it's positive, so I know it's going upward. So my end behavior on the left is going to be going towards infinity, and my end behavior on the right is also going to be going towards infinity. Next up, we want to find our zeros. So I know to find my zeros, I'm just going to say that 0 equals x, 2x plus 3, x minus 1 squared. I'm going to get my zeros at x. Here's my zeros. I'm going to get my 0 at x equals 0, negative 3 halves, and 1 with a multiplicity of 2. Since we have this x minus 1 squared, I have a multiplicity of 2. So there are my zeros. Next up, we want to go ahead and find some additional points. So I went ahead and made a table down here. Now, this is very important when graphing polynomials, so make sure you write this down in your notes. Put it on your bathroom mirror so you see it every day and you never forget it. When you're choosing your points for your table, notice I've already filled out all my zeros, right? I put negative 3 halves, which is a 0. I've got a 0, which is a 0, and a 1, which is a 0. And those are just the zeros that we just found. We want to find points that are in between these x values. Points that are in between these x values. So, for this point in here, I'm going to go ahead and I'm going to pick a number in between negative 3 halves and 0. I think a nice easy one to pick would be negative 1. So I'll go ahead and pick negative 1. I also want to pick a point right between 0 and 1. Well, I'll go ahead and just choose 1/2. These points are going to be very important to us in helping us graph. I went ahead and found our f of x values. For negative 1, I got negative 4. For 1/2, I went and changed that to a decimal, and when you plug that in up here, you get 0.5. So now we've got our table. Alright, here we have our coordinate plane here, and I'm going to go ahead and start by plotting my zeros. So here I have zeros at 0, negative 3 halves, and 1. So I know I have 1 at 0. I know I have 1 at negative 3 halves. That's negative 1.5. And I know I have a 0 at 1. Okay, next up, I'm going to go ahead and plot my additional points. The additional points I got were negative 1, negative 4. That's going to be negative 1, negative 4, all the way down here. And my other additional point was 1/2 0.5 or 0.5. That's going to be 0.5 right about here. And now it's really just playing connect the dots. But you have to keep in mind your end behavior here. For on the left, I know it's going up to infinity. So I know I'm starting up here in the up direction. I go ahead and down here, I connect my dots, connect my dots, connect my dots. Then when I get to my last dot, I want to go ahead and check what my right end behavior here is. My right end behavior is to positive infinity. So instead of continuing down this way, since my end behavior on the right is positive infinity, all I do is I turn right back up towards positive infinity. And we've graphed this function up here, right down here. We found our zeros, we plotted some additional points, used your end behavior, connected the dots, and you've got a function that probably a couple years ago would have scared your pants off. But now you are very capable of doing this yourself. So do some practice. It's really just repeating the process. Determine your end behavior, find your zeros, pick some points, and connect the dots.